Very good evening to all. So very good evening to all. I hope my voice was clear for you. So very good evening to Early Commerce, Bharat Singh, Vamsi, and then Vaishnavi, PV. Very good evening. Thank you for your presence in this 30-day masterclass on advanced VLSI design and verification. So very good evening to all. Sri Krishna, very good evening. Thank you for your joining. So very good evening to one and all. Let's wait for a few minutes and then we will start. I hope my voice is clear. If my voice is clear means just put yes in chat box. So Jayaprakash, yeah, thank you for response. Yeah, Sukanya, Radhika Kumar, Radhika Kumar, very good evening. Venkat, very good evening. So thank you for your joining. So Gangster John Danger, very good evening. Thank you for your presence in this 30-day masterclass. Yesterday we seen sequential logic. So today we are gonna see a setup time and then FSM related things. So today we are gonna see the timing related things, setup time, hold time, which fully based on the clock, the sequential circuits. We know that sequential logic will work based on the clock only. So there are some issues in while dealing with clock, like a timing issues. So let's see one by one in this session, setup time, hold time. So yesterday also we seen some details about setup time, hold time. So today we're gonna see that also, and then we will see the FSM types, melee type, more type, what is FSM, so how FSM are working in digital sequential design. So Nandini, good evening. Annamoli, very good evening. So Samaya, very good evening sir. Yesterday's topic interested today. So thank you for response, thank you for interest in this IDT masterclass. It's very pleasure for me. So let's see one by one. So today our plan is to cover the setup time, hold time, and then cover also FSM, finite state machine. It has two types, Moore and melee machines. So let's see one by one, what is a melee machine, and so on. So and then tomorrow we'll enter into coding part, Verilog design code. So how to write the Verilog code syntax, and then we'll move to the SystemVerilog. Okay. So before going to enter into verification, you must have some knowledge in design, how to write a design code for your circuit. Okay. So Siddharth, very good evening. So Ravi Khan, very good evening. Reddy, good evening. So I think we'll start our session. So yesterday we seen like a setup time, hold time. So what is setup time, hold time? So there are while dealing with clock, there is a time called setup time, hold time. And the setup time period, the transition of signal must be stable. So I will show the picture, then you can easily understand. So what is setup time, hold time? So here is a one clock passage, sometime before the passage and then sometime after the passage. So the signal must be same. So what signal means, for example, if you take a D flip-flop as example, so clock will continuously toggling, so at the particular passage, you are giving your input signal of D flip-flop must be stable in before the passage, and also after the passage the input of D flip-flop must be stable, then only you will get the correct output. Okay. For example, I think it's clear for you. Before the passage and after the passage, the signal must be stable. That signal may be input or output. Okay, that before the passage and after the passage, the particular signal must be stable. So while writing the Verilog code or while dealing with the sequential logic, some mostly signals are depends on the signal transition, and then signal value assigning are fully depends on clock pulses only, clock passages or clock negages. So if you take a passage of clock, before the passage, the signal whatever written, so what you are dealing with signal must be stable. So it's look like this only. So before going to that, you must know what is rise time and falling time. So you can see here is a transition, like this is a one clock input, one clock cycle. So there is a transition between, here's a transition like a 0 to 1. Okay, you can see here this is a low, this is high, so there is a transition 0 to 1. So clock won't change sharply 0 to 1. So it will take some to it will look like this only. So it will change from 0 to 1, but it won't change directly so sharply at the same time. It won't change 0 to 1. It will take some time. So like this it will take some time. So initially it having the 0 value, and then it will gradually increasing the value 0 to 1. So it won't sharply increase the value. It won't change 0 to 1 sharply. It will take some time to change from 0 to 1. Okay, I think it's clear for you. So you can see here there's a graph, like there's a transition 0 to 1. So it will take some time. So from 10% to 90% of transition, it takes some time. So that's the time is called like a rise time. Okay, I hope it's clear for you. Rise time is nothing but the transition between the 0 to 1. It will take some time. So every clock will won't sharply change 0 to 1. So like this it won't change. It will change gradually from 0 to 1. Okay, this is a graph look like what I'm saying. So it will change 0 here, it will 1 here, it will change 0 to 1. It will take some time. So that time is called rise time. And same thing also falling time. So you can see here, you can see here it is a 1 here. It will change, the clock change 1 to 0. So it is a falling edge or fall time. It will take some time to change from 1 to 0. So this is a thing very important. So the clock having some rise time and then fall time. While in the rise time and then fall time, the signal must be stable. So what you are dealing with based on the clock edges, that particular signal must be stable while clock fall time and then rise time. If it is any changes happen means you will get the metastability state. Okay. So Sri Satya, what is duty cycle in clock signal? So duty cycle is nothing but one duty cycle is nothing but one clock cycle is a one duty cycle. For example, so this is one clock period. One passage to another passage, or one falling edge to another falling edge. In between the one passage, this is a one passage. Sorry, this is one passage. So here 0 here 1 here. So this is one passage, and then this is one passage. So from one passage to another passage is known as one clock cycle. Okay, or else it will start from high, it will end from low. So this is called one clock cycle, one clock window, one duty cycle. Okay. So the time taken, the duty cycle of time taken is depends on frequency. So which is based on the frequency, clock frequency. If the 50 minutes of clock frequency having some time, so total that you can see here they say one clock period. One clock period, it is nothing but one passage to another passage and one falling edge to another falling edge. So from 0 to 1. Here low time and the combination of low and high, it's called one clock cycle, or one passage to another passage is known as a one clock cycle. So this is a one duty cycle. The time taken of the one clock cycle is depends on frequency. What you are given frequency for clock, it is based on the time taken is based on the frequency. Okay, how to calculate the frequency with duty cycle? How to calculate the frequency with duty cycle? For example, I will take one notepad, paint. So I'll just draw some sample clock here. Okay, this is one passage, and then this is also one passage. So there will be time taken for one clock cycle. This is for example, I'm taking is 20 nanosecond. Okay, So this is the time taken. So from this is one passage, and then this is one passage. This is one clock cycle, one clock duty cycle. From this passage to this passage is known as one clock cycle. The time taken off for one clock cycle is 20 nanoseconds. So how we can find the frequency? I know the time taken for one clock cycle, 20 nanoseconds. It means 5 nanosecond off time, 5 nanosecond on time. So this is the one clock cycle. 5 nanosecond off time, sorry, 10 nanosecond off time, 10 nanosecond on time. So this is one clock cycle. So I want to know the frequency, means you can there is one calculations like a nanosecond into frequency. Like if you know the formula of F equal to 1 by T, so F equal to 1 by T is nothing but frequency is directly inversely proportional to time. Okay, that's if you apply the like for example, I will use the calculator. So F equal to 1 by time. So I know that time. I want to know the frequency. So frequency means 1 divided by time, 20 nanoseconds. 20 nanoseconds is nothing but 2 power 10 into 2 power 9. So I think 10 into 10 power minus 9. If you apply that calculations, so I will show in the website. Nanoseconds into frequency conversion converts nanoseconds. So I will get the I want to see output in megahertz. Okay, so if my clock period is 20 nanosecond means I will get, so this is a 50. You can see here my clock cycle. So for one clock cycle it will take time of 20 nanoseconds. Okay, so I want to know the frequency, means there is one formula called F equal to 1 by T. If you apply the value, means you will get the frequency. So I am using some calculator from nanosecond to megahertz calculations. I'm just converting nanoseconds into megahertz. So 20 nanosecond means for one clock cycle, that clock pulse is based around the 50 megahertz. So 50 megahertz of clock having the 20 nanosecond time for one clock cycle. Okay, 50 megahertz of clock having the 20 nanoseconds to make one clock cycle. So one clock cycle is nothing but one passage to another passage, or off time and on time. So this is how we can calculate the frequency based on the clock cycle time. Okay, I hope it's clear for you. If it is clear for you, means just put S in chat box. Conversion of the nanohertz to frequency, and then to know the frequency based on the clock cycle time taken. It's clear for you, means just put S in chat box. So my main thing is my time taken of one clock cycle is 20 nanosecond. So I want to know the frequency. So you can apply the values into formula of F equal to 1 by T. So you will get the frequency. So what frequency that clocks are using. So I'm using some calculator. It will do converting of 10 nanoseconds into frequency. Like frequency means what is the clock frequency, we can know that. So if the time taken for one clock cycle is 20 nanosecond, means that particular clock is having the 50 megahertz of clock frequency. If it is 100 megahertz means the time taken will reduce. Why? Because of frequency increase means time will be reduced. So if I'm using the 100 megahertz of clock, means the time taken of one clock cycle is 10 nanosecond, 5 nanosecond is off time, 5 nanosecond is on time. Okay, it's clear for you? Yes, it's clear. Thank you for response. So this is how we can find the frequency based on the time, and also we can find the time based on the frequency. So it's a vice versa. Okay, let's see the setup time, hold time. So I hope it's clear for you. Rise time, fall time. So the clock won't change sharply from 0 to 1. It will take some time to change 0 to 1, 1 to 0, like this. That time is called rise time and then fall time. Okay, so why? So this is one example for setup time, hold time issues. So you can see here, this is a clock, this is on passage, and the passage, the setup time, you can see here, this is our input is on the time, on the passage time, and the setup time, the input is in the stable state. So there is a, you can see here, stable high, you can see here 1 here, so it is in the stable, but in the whole time there is a changing, there is a changes between, there is a changes. Why? Because of it will change 1 to low, the input signal, it is changing from 1 to 0. So 1 to 0 means there is a changes happened in whole time. So our rule is the signal, the input signal or any signal must be stable in setup time and then whole time. So if it is if there is an unstable happens, means you will get the metastability outputs, you will get the random junk outputs. So that is called whole time violation. You may receive some unpredictable output. Okay, that's why I'm telling the signal must be stable in setup time and then whole time. Okay, if it is any mismatch happens, if it is any unstable happens, means you will get the wrong value, so you will get the wrong output. And then this is a correct example for setup time, whole time. So you can see here on the passage, before the passage having setup time, after the passage having whole time, the signal, you can see here, input signal stay in the high state, high only in the setup time also, in the whole time also. So this is a correct like a correct value, so you will get the correct value as output. Why? Because of it is satisfying the setup time, whole time. The input value is stable on setup time, whole time, so you will get the correct value. If any unstable happens, means you will get the wrong value. So this is called timing violation in digital design. So it will mostly affect the sequential logics. While dealing with the sequential logic, you will receive some setup time, whole time violations. So we will see one by one how to rectify the setup time, whole time violations. So there are a lot of methods to rectify the setup time, whole time violations. The basic thing is, you must know the signal must be stable in the setup time and then whole time. Otherwise, if it is not stable, means you will get an unknown values. Okay, it's clear for you. If it is clear for you, means just put as in chat box, then only I can move forward for further topics. Okay, so this is a rise time, fall time, and then setup time, whole time. These are main basic things you must know as a VLSI engineer. Okay, so Roshni asked some questions. If we have TRD flip-flop or JK flip-flop, the frequency is 6 with 50% of duty cycle to calculate. Frequency is 6. So you can calculate the duty cycle by based on the frequency. You know the frequency. You can make the based on the frequency, you can know the time taken up for 1 clock cycle. So and then 50% means 50% of on time, and then 50% is off time. So you can easily find the duty cycle of the clock. So how many nanoseconds it will take, how many nanoseconds it will take make 1 clock cycle. Okay, so repeat again, bro. So this is the main thing. The signal must be stable. So for example, if you take an D flip-flop, the input is given to D flip-flop, assume like here having D signal. So on the passage of clock, before the passage and after the passage is known as setup time, whole time. So this is known as setup time, this is known as the whole time. So while giving input for D flip-flop, at the passage, before the passage and after the passage, the D value, so input value must be stable. It must have 0 or 1. So here you can see here it is staying in the high only. So high means logical high, it will stay in the high. So it is stable at the setup time and also whole time. So if it is like this, means there is no issues, you will get the correct value as from the D flip-flop. If anything happens like this, so here you can see here in the setup time, it will look like correctly, so it will stay in the stable state, but in the whole time it is changing. So it is changing from 1 to 0. Here there is a transition in the setup time, whole time, from 1 to 0. So this is called hold time violations. So if anything happens in setup time, hold time, unstable state means you will receive the unknown values. So while writing the Verilog code, you may receive these kind of errors. Okay. So I hope it's clear for you. So and then I will move into FSM. So I think it's clear for you, Radha Krishna. FSM like a setup time, hold time. The main thing is there is a two time, setup time, hold time. So before the passage, before the some time of passage, after the some time of passage, the signal what we are dealing with signal. It may be input, it may be output. That signal is that signal is based on the clock process itself. So that signal must be stable while in the setup time and then hold time. Then only you will get the correct value, correct results. If it is any unstable happens means you will receive the unknown values. So how you can practically see this difference if you want to practically do this setup time, hold time violation means you can write the design code for D flip flop, and then based on that these clock issues you can give the input. So I think tomorrow I will give some basic explanation and also basic demo of the setup time, hold time issues. I will give tomorrow. So I will give demo tomorrow. So main thing is hold time, setup time, the signal must be stable. So this is the main thing you have to know. So and then we'll move into the FSM. So FSM is nothing but if you guys know the metro entry point. So while entering the metro, you have to give some input. Input means you may swipe the card, you may put the coin into metro gate. Okay. So for example, ATM machine also an example for FSM. So firstly you have to enter the ATM card, and then you have to choose the language, and then you have to choose the account type, and then you have to enter the PIN number, and then you have to enter the amount, and then you will get the cash. So for getting the cash you have to follow these these steps in the ATM, same like FSM also. So here to achieve one sequential logic, you can divide the sequential logic in several parts, and then then completing one by one you can achieve the results. So this is how sequential FSM is working. So FSM is only for sequential circuits. So why? Because of sequential circuits will works based on the current input and also previous output. So it will the sequential logic will consider current input also and then previous output also. It's like a memory state. So that we have to follow some FSM techniques. So this is one example. The FSM for example, if you want to example for FSM means the ATM machine is also one example of FSM, and also traffic light controller. Traffic light signals also one example for FSM. So based on the traffic counts, traffic in road, it will give the signals red, green, or yellow. Sorry, orange. So for example, if there is a high traffic in one road, so that sensor will automatically find that there is a traffic in this particular road. So that signal will blink as a red. So it is fully based on the sensor input and then memory state. So I will show you one by one how it is work FSM. It having the two types, Miller type and Moore type. Okay. So FSM is a mathematical model used to represent the sequential logic circuit. It consists of finite number of states and then transition between the states based on the inputs. Okay. So and then commonly it's used in the digital design. So for example, so if you want to achieve one logic in sequential logic means you can divide into several parts. So firstly you have to complete to one state and then you can move into next state. So for example, you are studying in college. So after the college you have to go your home. Then first what you will have to do. So firstly you have to take a bus from your college, and then you have to travel some distance, and then you have to reach the bus stand. It's near for your home, and then you have to walk some time to reach the home. So there are a lot of stages. While if you want to reach the home means there are a lot of stages you have to follow, you have to you have to complete. So that is based on that. So like that FSM will work. So to complete one sequential logics, to complete one sequential circuit means you can divide the circuit one by one. So you can divide the circuits. So you can you have to complete one by one stages, then only you can achieve the results. So based on, so this is a basic definition of FSM. It having the finite state of finite states. So states is nothing but each and every state will help to complete the task or problem or logic. Okay. So if components of FSM, it having states to designate the continuous or configuration, and then inputs. So inputs is nothing but external signals that influence the state transition. So for example, you having one state, so you want to move from one state to another state means how you can move. Based on the input only you can move. If it is input is satisfied for that particular state means okay, that particular first state is completed, then you can move into next state. So and then next state having some input. So based on the input only you can move into further states. Okay. And then output. So output is depends on current state or inputs. And then state transition. So movement from one state to another state based on the input values. And then state registers, it will hold the current state. Okay. So and then example for the FSM is traffic light controller. So example for Murray machines, states are red, green, yellow, and the inputs maybe inputs are getting from timers or sensors, and then outputs are a light color of vehicles, light color for vehicles, and then by walk peoples, pedestrians, and then transitions. So transition means nothing but change the state based on the timer. Okay, so based on the timer it will change the state. So based on the timer it will change from red to yellow, yellow to red, green to yellow, and then yellow to green. So based on the time input it will change. So this is example for Murray machine. So it having two types, Mealy machine and then Murray machine. So Murray machines having some definitions. So Murray machines output depends only on the current state. Okay, it is simpler to design and then analyze. For the example of the Murray machine is traffic light controller. So based on the one input it will change the state. So based on the timer input for time traffic light controller, it will change transition state from yellow to red or green to yellow kind of thing. Okay. So and then Mealy machine. So Mealy machine is nothing but output is depends on current state and also current input. So it is faster response to input changes, and then it is helpful for your sequence detector. So I will tell you what is a sequence detector. So this is a basic difference between the FSMs. So Murray machine, Mealy machines. So output for Murray machines output depends only on current state, but in Mealy machines output depends on both current state and then current input. So current state is nothing but it is a memory elements. It will store the previous output, so that is called current state. And then current input is nothing but what we're giving the current input for state, it's a current input. So and then response time. So Murray machine it will perform slow. So and then Mealy machine it will perform fastly. So and then design complexity. So Murray machine easier to design and debug, Mealy machines more complex due to input dependency. So and then why it is more complex means this Mealy machine will consider both current input and then current memory state. Okay, current state. So and then state transitions, like a state requirement. Usually it requires more state to implement behavior, but here Mealy machines it requires a limited number of states. So and then output stability, so more stable. So but here in the Mealy machine output can fluctuate with input changes. So it is example for Murray machine traffic light controller. It is example for Mealy machine sequence detector. Okay. So I will tell you the what is a sequence detector. So for example, so before going to that, I want to announce one things regarding the internship program. So if you guys are really interested in this master class, you can convert into 1 month of internship on advanced VLSI design and verification. So if you guys are really interested, you can convert this 30-day master class into 1 month internship on advanced VLSI design and verification. So from this internship program you will get the benefits of these all 8 benefits, like you will get the 30 days recording sessions, and then you will get the all the PPTs, and then you will get you can also download the PPTs source codes, and then you will get the 4 plus exclusive projects, and then you will get the confirmation letter from IETE. So and then you will get the 180 days LMS course access. Okay, and then we are providing, so it is literally 6 months access of recorded sessions. So and then you will get the assignment. We are providing the weekly live sessions. So and then we are providing the weekly assignments. So if you have any doubt means you can ask in weekly live sessions. So and then you will get the academic internship report. So if you are studying in college students, if you want to internship programming, so you can purchase this, and then you will get the report also. So and then high valued IETE certificate. So internship certificate from the IETE, it is a central government institution. So IETE, so these are the benefits. You will get the internship program at the discounted fee of just 999. So our regular fee is 499. In this masterclass period we are providing at the discounted fee of just 999. By using this registration link you will get the internship program, and also you will get this link in chat box. So and then, so after the clicking, if you guys are really interested, you can buy this internship. After the clicking this internship like internship registration link, you will see this window in the domains form. In the domain side you have to choose the advanced VLSI design and verification. Then only you can get the internship program on advanced VLSI design and verification. So and then you have to fill these basic details. It's very compulsory. So after that you will get the internship program, and then you will get the, after the completion of 1 month, you will get this certificate, internship certificate from IETE. So this is sample certificate. It will look like this only. So you will, if you guys are really interested, you can get this internship program by using this link. So our discounted fee is just 999. It is a limited time period offer. If you guys are really interested, you can avail it. So and then we'll see the FSM. We've seen already FSM. So let's see one by one, melee type and then more type. I hope it's clear for you guys. Setup time, hold time. Actually all these days students are in holidays. I hope it's clear for you. Setup time, hold time is very important thing. I hope it's clear for you. And then I will move to the melee type, more type FSM. So already we seen the definition of more type. So this is the types of FSM. So more type, in the more model, the output is a function of only the present state. Okay, the output of the function. So in the more type will output is depends on only based on the present state. So this is a basic logic diagram of more type FSM. So this is output logic, this is a combination logic, output logic. So okay, the output is depends on only the present state. Present state is nothing but this is a next state logic. You are giving the input to next state logic, and then you are storing, you are giving the input to D flip-flop. It will store. This is a current memory state. This is known as memory state. So it will give the, based on the clock input, it will give the output. Then it will give the output to the output logic. It will give the, and then it will finally give the output. Okay. The main thing is output is depends on current state. Current state only. Okay. Current state or present state. So and then this is a logic diagram of melee type. So output is depends on both current state and then current input. So this is my input signal. So output logic is depends on current input and also memory state of the melee type. So this memory state is nothing but it will store the previous output value. So previous output. Okay. So this is an next state logic. It will store in I will store into memory elements. So and then it is depends on current input. This is my current input. So it will I am using directly. So and then memory elements. So memory element is nothing but our previous value are stored into memory. So okay, the output is depends on current state and then current input. Okay. So and then it having some overlapping and non-overlapping. So for example, FSM, I will show the sequence one example for overlapping, non-overlapping. So I will show the sequence detection. Sequence detection. So you want to detect. So you want to detect 1011. So you want to detect this sequence. Okay. You want to detect. So you want to detect this sequence. So here, but you assume like you having one machine. That machine will do the sequence detections. So that machine is having some inputs. So inputs like it having some one by that particular machines receiving inputs one by one. Like a serially it will receiving the inputs. Like how it means 1011 So this is a serial input for that sequence detection machine. So you want to detect this sequence. Okay, if you want to detect this sequence like a 1011, so that you having assume like you having one machine. So it will receiving the binary bits, binary inputs 1010 continuously. It won't receive packet kind of thing. It will receive one by one, like a serially it will receive one by one. So this is the input. So that particular machine have to do the sequence detection. So it will always looking for 1011. So when it is comes 1011 means if it is occur means the output will be high. So for example, the machine will looking for each and every bit. It will firstly it will start from here and then it will come here 0, and then it will come here 1, and then it will move, and then it will check another input, and then it will continuously checking the input 1010101010. But here it will continuously checking the input. So this is I want to detect firstly 1 and then 0 and then 1 and then 1. If I detect this sequence means I can say I am getting I got my output. Like that it will work. So for example, if you taken here up to this I didn't receive any sequence. Okay, but here firstly I'm getting 1 here I'm getting 1, and then here I'm getting 0, here I'm getting 1, and then here I'm getting 1. So this is my sequence. At the time I got my sequence, so I can say that I'm getting 1. I can say that I got my sequence output. So just I put here 1. This means I got my output 1011 at the stage of this. And also here also I'm getting my sequence 1011, so it will give the output at the state of last bit. Okay, so this is FSM will work. This is a sequence detection work. Okay. This is non-overlapping. So why it is non-overlapping means the each and every sequence having some separate outputs. So if I change the sequence, if it is non-overlapping, so there is no overlapping happened here. Okay, so and then you can see here this is one sequence 10101011 is my this is one sequence, and also 1011 is also one sequence. So the two sequence this is a two sequence, but they are overlapped. So the first bit of the second sequence it's based on the previous sequence output. So this is a overlapping. Okay, if it is there is no overlapping means so each and every sequence separately. So separate means it having some own output like a 1011 own sequence output. It's called as non-overlapping. If it is used the previous thing, it will use the previous output means it is known as overlapping. Okay, so and then so I want to detect. So this is a FSM diagram. So overlapping is nothing but FSM can reuse some part of the detected sequence for the next detection. Okay, so non-overlap is nothing but after detecting the sequence, it is reset to the initial state and wait for the next sequence. Okay, the overlap begins, it can reuse the previous output. Okay, to find the next detection. But in non-overlapping, it won't use the previous output. Okay, this is a non-overlapping. So this is example of overlapping of Murray type. So you can see here, this is one FSM state diagram. I hope it's clear for you, it's visible for you. So I want to detect this sequence 1011. So while drawing the FSM diagram for Murray machine, means you have to follow that rule. So you want to detect 4 bits. Okay, 1011. You want to detect the 4 bit of the binary inputs. Okay, so for that you have to make the 5 states while dealing with the Murray mission. 4 bit detection means you have to make the 5 state S0, S1, S2, S3, S4. Okay, so this is the 5 state you have to create firstly. And then so each and every state, you can see here S01, it's my first state, S1 is my second state, S2 is my third state, S3 is my fourth state, S4 is my fifth state. So totally I am having the 5 state, each and every state having the input and outputs. So you can see here, this is my input and this is my output. So each and the transition of the state is based on the inputs. Okay, current inputs only. So for example, if I detect I want to detect first is 1. If my input is 1, I can move into my S1 state. If my input is 0, I am staying in my the same state. Why? Because of I want to detect only the 1, so 1 value. So for the state transition, if I receive for example, if you take like S0 state, the S0 state will receive the 1 input, means it can move into next state. If it is receive the 0 input, means it will stay in the same state. Why? Because of I want to detect the 1011. So 01 is my first bit want to detect. So if it is S0 state, the input is 1, means it can move into S1 state. In the S1 state, if it is input is 0, means it can move into S2 state. If it is 1, means it will stay in the same state. You can see here, input is 1, this is the output. Okay, this is output. The like S0 by 0 means this 0 is refers to output, this one is refers to input. Okay, this one is also refers to input. So and then for the S2 state, if I receive the 1, means I can move into S3 state. So or else if I receive for S2 state, if the input is 1, means I can move into S3 state. Why? Because of my third bit is 1. If I receive in here 1, means I can move into S3 state. If it is 0, means I will move into S0 state. Why? Because of I'm continuously finding the inputs, finding the sequence 1 0. I got 1 0 sequence, but here in this third state I am receiving 0 here. It means 1 0 0. So it means I totally lost my sequence. So I want to start from beginning. So that for that reason it will move into S0 state. Okay. So here I'm got S0 state. Here if it is got in the S2 state, it will receive 1, means it can move into S3 state. Here if the S1, in the S3 state, if it is receiving 1 as an input, means it can move into S4 state, and that time output will be high. Why? Because of I got my sequence. Why? Because of I received 1 0 1 1 correctly. So I can declaring as output equal to 1. So this is output signal. So you can see here up to the S3 state, the output signal is a low only. So but this is output signal, this is input signal. So when it is we will get the output, means at the final state of the FSM only we will get the output. So I got my sequence 1 0 1 1, so that I can put 1 here. So at the S4 state, at the S4 state I got my output, so I just put 1 here. If it is in the S3 state, if it is 0, means it will go to the S2 state. Why? Because of, if it is 0 means in the S2 state there is a chance to get the 1, so it will go to the S2 state. Okay, so this is a FSM for Murray type 10111 sequence detection non-overlapping. So we'll see the overlapping. So overlapping is nothing but, so you can see here, after the getting the sequence, it will move into S0 state. It means initial state. So if it is moving to initial state means it is known as non-overlapping. If it is move into, so after the S0 state, it will move into S2 state. So it will reusing the sequence. It will reuse the sequence. So I can say that it is a overlapping. If it is moving to initial state means non-overlapping, or it will use the state. It will use the state again means it is a overlapping. So this is a more a type of FSM. Okay, some people won't understand this, so please refer personally, then only you can understand. The main thing is state transition is based on the current input only. Okay, current input, not the based on the previous output. So this is a Murray type. So and then I will show you the Murray type FSM. Same sequence detection, Murray type. So this is a Murray type of non-overlapping. So here the output is depends on current input and then current state. So in the Murray machine you can see that output is in the state, but here output is in the transition. So you can see here 0 by 0. It means the numerator is refers to input, and then denominator this is refers to output. Numerator is refers into as a input, denominator is refers as a output. Okay, so I want to detect the sequence, what sequence means 0 1 1 1. So this is my sequence 0 1 1 1. I want to detect this sequence. So I will continuously using some binary inputs, one by one I am getting the inputs. Okay, so I want to detect this sequence 0 1 1 1. Once I got this sequence means I will give the output as 1. Okay, this is a working of FSM. So if not FSM, sequence detection. So in the Murray type, in the Murray machine, if you are dealing with 4-bit means you have to create the 5 states, but in the Murray machine you required only 4 state only. If you are dealing with 4-bit means you have to create only 4 state, no need to create 5 state. Okay, so and then here I am created the 4 state S0, S1, S2, S3. So here this numerator is refers to input, and then this denominator is refers to output. So here assume like this is my first state. So I want to detect the 0 for in the first state, S0 state. If it is 1 means I am staying in the same state. Why? Because of I want to get the 0 input for my first state, S0 state. So if it is 1, if my input is 1 means I am staying in my first state. Okay, here you can see here input is 0, output also 0. So input is 0, so this is my requirement. So first in my first state I want to get the output I want to get the input as 0. So if I here I got my input for the S0 state is 0, so I can move into S2 state. Okay, so and then in the S1 state I want to get the input as 1, then only I can move into S3 state. So if my input is 1 means I can move into S2 state, but if my input is 0 means I am staying in my I'm staying in my S1 state. Okay, I'm staying in my S1 state. So you can see here up to the S1 state I got first sequence 0, and then if it is 1 means for S1 state, if it is input is 1 means I can move into S3 state. So up to the S3 state I got sequence of 0 1. Okay, so if it is in the S3 state, if my input is 1 means I can move into S3 state. Okay, you can move to S3 state. If it is 0 means I am going to my S1 state. Why I am going to S1 state means here I already having the 0 value. So and then there is another chance in the S1 state will get to 1 to move into next S2 state. Okay, the main thing is if for the S2 state, if my input is 1 means I can move into S3 state. Okay, so till now the S3 state I got a sequence of 0 1 1 1, but I need 0 1 1 1. I need another bit input. If the S3 state input is 0 means it will going to the S1 state. Okay, if the S3 in the S3 state the input is 1, so it means I got my sequence 0 1 1 1. So I will put output, I'm signaling output is high. Why? Because of I got my output, so I can declare output is output equal to 1. Here I'm putting 1, and also input is 1. So in here in the S3 state output input is 1, so I got my sequence, so I'm putting 1 here. So and then I'm going into S0 state, it means non-overlapping. So till after the S3 state I got my sequence 0 1 1 1. Okay, but if the input of S3 state is 0 means it will move into S1 state. Why? Because of already we having the 0 in the S1 state. So and then there is another chance to get the 1 in the S1 state. We can in the S1 state having input. Okay, so there is another chance to get 1 here, so that we can move into S2 state. Okay, that's why it will going into S1 state with the S1 state without going to S0 or S2. Okay, here is in the S1 state itself having a lot of possibilities to get the next value. Okay, next value is nothing but next required input. So till now it is a non-overlapping of Miller type. It need force type. It is depends on current input and then current state. So here current state is 0, and then current state is 0 1 1, current state is 0 1 1. So if the input is 1 means it can I got my sequence, so at that I put 1 here. I'm going to the S0 state, it is initial state. If it is going to the initial state is nothing, it is, if it is going into initial state means it is a non-overlapping. Else if it is going into, if you can see here in the same thing, same Miller type, it is an overlapping. Why it is called overlapping means you can see also here input is 1, but it won't go into S0 state, it is going into S2 state. So it is reusing the state, it is reusing the previous inputs, so previous states. So that's why it's called overlapping. So you can see here after the getting one input in the S3 state, so I got my output, so I just put over here to give the signal for I'm getting the output. So I got my output based on the sequence 1011, sorry 0111. So and then it will move into S2 state. Why? Because of it is a overlapping Mealy emission. So it can move into S1 state, it can move into S2 state, or else it can stay in the S3 state to make the overlapping of FSM. So if it is 0 means for the S3 state, if it is 0 means it will move into S1 state. Okay, so this is how basic sequence detections are working. So this is very important. While if you are entering the Verilog code, you have to write the FSM code for all the logics. For if you taking like UART protocol, all the protocols are based on the FSM logic only. So you must aware of this FSM guided things: Mealy type, Moore type, state transition. So and then the main thing is Moore machine. It's based on output is based on the current state, current input only. But in the Mealy machines, the output is based on the current input and also current state. Here is a current input, current state is 0 1 1. My current input is 1, so that I can say that I got my output. So I just put 1 over here. If my input is 0 means, so you can see here, if my input is 0 in the S3 state means it will move into S1 state, and that time output is 0. You can notice here. Okay, I hope it's clear for you. So I think it's clear for you. If you have any doubt means you can ask now. It's very important FSM. So while the first time saying this, it is very difficult to understand. So please refer to yourself. You can easily understand. So if you guys any doubt, you can ask now. So FSM, Mealy type, Moore type. The main thing is Moore machine, its output is depends on current input. And in Mealy machine is output is depends on current input and also current memory state. Okay. So do you guys any doubt? Do you guys any doubt means you can ask me. So Narayana Murthy, yes. So can you ask? So can you tell the topic? So which part you have doubt? Whether FSM or setup time hold time. So FSM is nothing but we are dividing the our logic to get the full working logic. So I want to detect this sequence. So but I am getting the one by input. So I am getting assume like this is the Mealy machine. This is on box. It will do the Mealy machine or non-overlapping technique. So here I am getting the binary inputs one by one. So it will detect one by one input. Once if I got 0, 1, 1, 1, binary input means it will blink the LED. I got the output sequence of 0, 1, 1, 1. This is how it works. Okay, it's clear for me. Thank you for response in Narayana Murthy. So do you guys any doubt you can ask now. I think this is for today. FSM and setup time, hold time. So and then if you guys are if you guys are have any doubt means you can ask now. So main thing is FSM need extra while dealing with the states. FSM need extra state, but in the Mealy machine we need only exactly what we exact states only. 4-bit means 4 state, but in the Mealy machine 4 state means you need 5 states. Okay. So I think it's clear for you. I hope clear for you guys. Setup time, hold time. So signal the signal whatever you're dealing with signal, that signal must be stable. Not the dealing with signal. All the signal must be stable in the setup time, hold time. This is a passage. This is a setup time, hold time. All the signal must be stable in the setup time, hold time. Then only you will get the correct output. Okay. And then you can see here the data changes. So data can toggle in this region. So in the low time, in the high time, the data will toggle the data can toggle in this region. So data can change in the high time, in the low time. But here in the transition of high to low, low to high, or setup time, hold time, the signal must be stable. Okay. Sir, can you explain please Mealy overlapping sequence? Mealy overlapping. So Mealy overlapping. So assume like this is a Mealy machine. This is a one hardware. It will do sequence detection Mealy type. So the input I am getting. So here I am giving input one by. I am not giving the bulk bits. Like I'm not giving the 4-bit input or 3-bit input. I am giving the only 1-bit input at a time. 1 0 1 0 1 0. I am giving input to this Mealy machine. It will detect. How it will detect like I want to detect 0 1 1 1. It means this machine have to detect 0 1 1 1. After getting this sequence, it will blink one LED. This is output signal. So I am giving like a firstly 0 and then 1 and then 1 and then 1. So after this sequence, the Mealy machine will find that. So I am getting correct sequence. So I will blink the LED. Okay, this is how Mealy machine work. So this is the basic of Mealy machines. So for that sequence detection, each and every bit is a one state. Firstly, I need to get the input 0 and then 1. So 0 is my first state, and then second bit is my second state, and then third bit is my third state, and then fourth bit is my fourth state. So firstly, I want to complete first state, second state, third state, and the fourth state itself. By the fourth state only, I can say that my sequence is correct. So then only I can blink the LED. Okay. To determine that, I draw FSM diagram, logic diagram, FSM diagram. So this is how it works. So each and every state having inputs. Okay, it may be 0 or 1. So there is only two combinations of inputs. It may be 0 or 1. So in the S0 state, if it is input 1 means, so I am staying in the same state. You can see this arrow mark. I am staying in the same state. Why? Because of I need to detect in my first state as 0. Then only I can move to the next state. Next state is nothing but S1 state. Okay, so in the S1 state, if it is input is 1 means I am staying in the S1 state. If my input is 0 means this is my correct input for my first state, so I want to move to next state. So here you can see here the arrow mark is refers to moving to next state. My input is 0, my input is 0, and then my output is also 0. Can we see more with memory element sequential operation? Can we see more with the memory elements? So I will come to the question. So firstly I will clear the melee overlapping. So S1, so in the S1 state, if it is received the 1 means it will move into next state. Okay, you can see here in the S1 state it will receive the 1, so it will move into S2 state. Or else if it is received the 0 input, so it is staying in the same state. Why? Because of already we have in the memory element memory of 0, so already we got 0, so I can stay in the same state whether I can get the another input as 1. So and then in the S2 state, if it is input is 1 means I can move into S3 state. Okay, at the time output is 0. If it is in the S2 state, if it is input is 0 means, so I lost my sequence 0 1 until before the S2 state I have 0 1. If my input is 1, like if my input for this S2 state is 0 means I got sequence of 0 1 0, so it is not my sequence, so I want to start from beginning. So that reason it will move into S1 state. In the S1 state already it having 0. Okay, so if it is 1 means in the S2 state, if it is input is 1 means I got sequence of 0 1 1. Okay, so I can move into next state. In the S3 state, if it is 1 means 0 1 1 1. Okay, I got my sequence, so I can blink the LED, so I can give the output. So you can see here output is 1, but here I am going to, if I am going to the S0 state, initial state means it is not overlapping, so non-overlapping, but here I am going into S2 state, so I am reusing the state, so it's called overlapping. So you can see here if the input is 1, I got my sequence 0 1 1 1, so but I am going into S2 state, it means overlapping, so I am reusing for S2 for I'm reusing the state to detect the next sequence. I already got one sequence. If I'm reusing the state current state to find the next sequence, this means overlapping. So why I am going to this S2 state means to detect the next sequence. Okay, already I got one sequence, so I want to detect next sequence. If I reuse the sequence means it is overlapping. If it is not, if I am going to the initial state means I am starting from 0, so it comes under the non-overlapping. So and then if it is in this third state, if my input is 0, so it means I got till now S3 state I got 0 1 1 0. So this is not my sequence, so it is very wrong. So I will move into S1 state. Why? Because of already S1 state having 0 value. So and then I want to start from beginning 0 1 1 1. So this is how melee machine work. I think it's clear for you, Aish, or so normally. Okay, thank you for response. Can we use more with memory element for sequential operations? So I'm not clear with your question, Neka Kapil. Can we use more with the memory elements for, so more machine also use memory elements, but output determines based on the current input only. It will store. Okay, so and then it will give the output based on the current input. If it is 0 means it will give the output. Okay, outputs you can see here the output are in the melee machine, outputs are in the transition of states, but in the Moray machine outputs are in the states. You can see here outputs are in the states, not in the transition. Okay, that's why this is FSM. I think it's clear for you guys. Or thank you for your response. I hope it's clear for you. So do you guys any doubt from this session? You can ask now. So and then if you guys are really interested, you can convert this masterclass into 1 month internship program, internship on advanced VLSI design. You will get all the details recording session, internship program, and then you will get the source codes you can download also, and then you will get all the details PPTs, and then you will receive the weekly live sessions, weekly task, and then you will get the IETE internship certificate from IETE, which is Central Government certificate. So you will get these benefits, the program of internship program of advanced VLSI design verification. By using this link, you can get the internship program. Okay, this is the link. So and then after the link, if you click the registration link, you will see this window. In the domain sector, you have to choose advanced VLSI design and verification. Then only you will get the this internship program particularly. Why? Because of we are providing a lot of internship program, so you have to choose advanced VLSI design and verification. Okay, so and then you will get this certificate after completing the 1 month of internship program. So I think it's clear for you. So can I wind up the session? So tomorrow we'll see the introduction about Verilog, and then we'll write the Verilog code for combinational sequential circuits, and then we'll see the intro about SystemVerilog. So thank you guys, thank you for listening. So we'll see tomorrow.